So here's what we're going to do. So we're going to graph quadratic equations. So first of all, we know that a quadratic graphs a parabola. So the next thing I want to write down is this. The parent function is y equals x squared. And I know on my parent function that the vertex is at 0, 0. Next, I know if I put a 1 in here, what's 1 squared? So I get point 1 and 1 on here. Next, if I put a 2 in here, what do I get? 4. If I put 2 in, I get 4. And I know because of the axis of symmetry that we also get the negative version of that, right? We don't need to list them because we know we're going to get one on each side, right? Everybody gets that? Okay, so the next thing I just want to talk about just for a minute is when we talk about slope. Like what's in your mind, if you had to tell me what is slope, what would you tell me? So we get rise over run, we get, what else did you say? The rate of change, okay? So when we talk about slope, we normally think in our mind rise over run, and we think y over x. And the reason we think that is we're thinking of straight lines, right? We're thinking on a straight line. So when we say rise over run, I'm saying the y, and then the actual function for a line is y equals x. And that's why there's an x on the bottom. But this is y equals x squared. So my a value is going to be the change in y, the rise, over the change of x squared. Because on the bottom, the x is squared for a quadratic. Thank you. So we're going to get the rise over the run, but the run for a quadratic is x squared. Does that make sense to everybody? Because it's not a straight line, so we're going to put the x squared for x. All right, so if I look at my function on A, my first thing I want always is I want my vertex. And so my vertex here is -8 and 4. No, I know you can't see it, but I'm writing it here. So the next thing I want is I want my a value. So if I look at my function, I'm going to count from this point to an exact point. And it doesn't matter which point you pick as long as it's exact. So can we agree that this is an exact point right here? Okay, so my y, I'm going to go 1, 2, 3, right? I went up 3, and then I go over 1. So 1 squared is still 1. So my a value is going to be 3 over 1, or 3. So if I write my function then, it's in vertex form. We did that on our sheet. We all know what this is now. So my a is going to be 3 times x plus 8 squared plus 4. And that's going to tell me I have a vertical stretch of 3. I'm going to have a translation of 8 to the left and 4 up. Yes? So let's go to the next one, and I need you to pay attention for a moment. So first of all, somebody tell me what's my vertex. Whoa. Somebody who can actually tell me what the vertex is, speak. The rest of you don't talk. Thank you. All right, so the vertex is 6, -1. I thought that was like an easy question. Okay, so it's 6, -1. Okay, now, Now I want to talk about the A. Okay? I want the A value. That's what we're going to do. And we just said the A value is going to be the change in y over the change of x squared. Okay, nobody talk. So we have to find exact points. I'm going to start at the vertex, and I think this is an exact point. Does anybody think it's not? Okay, so my change in y is what? I count down 3. Is that correct? So I'm going to put -3 for my y. I put a -3 there because I counted down. Now, I counted down 3. How many do I count over? 3. So I counted down 3 and over 3. Does that make sense? But on the bottom, we said, what am I going to do to the bottom? I'm going to square it. So if I square it, 3 squared is 9. So y'all, if it's -3 over 9, what's my A value? So what did I count for 1/3? I counted 3 and 3, right? So what do you think I'm going to count for 1/2? 2 and 2, right? I'm going to go 2, and then 2 squared gives me 4. So that's 2 over 4, and that gives me my half. Right? Does everybody see this? Okay. Okay, so if I'm going to write my equation now, I'm going to get -1/3 x minus 6 squared minus 1. So we talked a lot about this when we did our transformations, y'all. This is a vertical compression, correct? Why is it a vertical compression? But what is less than 1? The negative or the 1/3? What's the negative? That's the reflection. The negative is the reflection, and the 1/3 is the compression. So I'm going to get a reflection over the x-axis. I'm going to get a vertical compression of 1/3. And I'm going to translate 6 to the right and 1 down. Are we okie dokie? Next, I'm going to have a reflection over the x-axis, which means which way is this parabola going to face? I'm going to translate 1 to the right and 3 up. So when I look at this, friends, my vertex is 1, 3. That's where I'm going to start. I'm going to start with 1, 3. And my A value is -1. So which way am I counting? I'm going to count down 1 and over 1, right? Okay, now here's what I need you to hear for the next one. So does everybody see I counted down over 1? My A value is 1. And we said my next point would be 2, 4. Is that correct? But since it's down, right, I'm going to count. I'm going to count over 2 and down how many? 2, 3, 4. And once I get that point, I get one on the other side as well, correct? So right here gives me that parabola. Which one? Correct. If you wanted, if I ask, so right here, y'all, this is your 5 points, right? Usually, standard and PAP and AP, they're going to ask for 5 points. Some of these, when they're going to be off the graph, so we're only going to do 3, but standard is 5. Okay? All right. So, y'all, my next one is, what is my vertex? -4, 0, and what's my A value? 2. So before I start, y'all, the 2 tells me I'm moving in the Y direction 2 and in the X direction 1, right? 1 squared is still 1. All right, so I'm going to have a vertical stretch of 2, and I'm going to translate 4 to the left and then. So I'm going to put -4, 0. So my first point would be 1, 1, right? I'm going to go up 2 over 1. Up 2 over 1. Because the 2 affects the Y value, right? It affects the Y value. So if I look at my next point is 2, 4. How many am I going to go up? I'm going up 8. You have to take the 4 times 2, right? So I'm going to go up 8 and over 2. What? This looks like 8 to me. I'm okay. Oh, you thought I was going? What? No. 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 That's just no. Yeah.
So I know 2 times 4 is because why would I put
Because you always multiply your stretch times the Y value. If it was inside, you'd multiply it times the X, right? But outside is always times the Y. Okay. Can you guys write the equation for E? Write it for E and F. And then we'll graph. Okay, did everybody get this one? If not, ask questions before I go. We're all good here on the first one? Okay, so let's start by graphing -6, -2. Now, where do I go from -6, -2? Down 2 and over, okay? Down 2 over 1, and we're going to do that on both sides. Y'all, how many would I go down for the next one? From the vertex, right? Not from the point. So I'm going to go down 8 and over 2. Okay, y'all, how many of you are okay with that? Yes? Any questions I can answer before I move? Like you feel like okay, we're okay, right? I feel like this is really, we're good. We should be pretty good with this. Okay, so I'm going to translate f of x equals x squared, right 5 units, up 4. I'm going to apply a vertical change of 1/2. Okay, so right away, I'm going to write this, but what did we talk about? When it's 1/2, what are we moving? How many? How many are we going to move for the 1/2? How many did we move for the 1/3?
No, two.
For the 1/3, what did we move? 3 and 3. So for the 1/2, we're moving 2, 2. So y'all, so the 1/2, right? The 1/2 equals, it equals my y over x squared, right? But do you know what something times the square root of 2? Can we graph it? No. And so that's why I'm moving 2 over 2. Because if I move 2 over 2, I get 2 over 4, which is 1/2. Y'all understand this? Okay. I don't want, like, I need you to understand it. Because it's proportional, right? We're moving a proportion is what we're doing. Okay. So let's go ahead and let's get at 5, 4. 5, 1, 2, 3, 4. Am I going up or down on this one? Up, so we're only going to do, we're going to do 2 points. And so I'm going to count up 2, over. And so this gives me, this is F here. This one is G. Okay, y'all. I'm going to hand out the homework, and I want to point out 2 things on it for you. Okay, y'all, the first thing I want you to look is the side that already has the graphs on it. I want you to look at A. Y'all, what would be the vertex here for A? Okay, so I have -8 and 0. So the next thing I need now is I need my A value. That's what I need. So when I was looking at this, at first I thought, like, is this an exact point? And I don't think it's exact. Does anybody? I don't think it's exact. So I think the best exact point I could find was all the way up here. So do you see that up there? So my A value is up how many? 10 and over how many? 2, and what do I do with that? So I have 10 over 4, which means my A value is 5 over 2. So if we were going to write this, I'd do 5/2 x plus 8 squared, and then plus 0, but we don't need the plus 0. So y'all, 5/2, what is that? A vertical what? Is it a stretch or a compression? Stretch because it's bigger than 1. Okay, the last thing I want to point out is on the back, the other side. It's on number E. Y'all, on all of them, when we write our equations, you see how there's nothing in front of the x, right? None of these, there's nothing in front of the x. Does everybody see that? Sometimes, when they write like E at the bottom, what's in front of the x? Negative. Y'all, you have to divide that out. I'm going to divide out my -1 here, and you have to rewrite it. And after I write this, you tell me why this is important. Why is it important to factor out the negative? What changed? The vertex, right? It changes what side you're on, doesn't it? Because the vertex is -6, 4. This one, if you look at it, you think it's 6, 4. So you have to make sure to divide out if there's a number in front. And also if there's a number. So for instance, if this was written, you see that 2 right there? You have to factor that out as well. I'm going to divide by 2, and I would make this 1/2. So what does the 1/2 mean? It's a vertical what? Compression. What does the 2 mean? Horizontal compression of a half, right? Because x's are lighter. So that's why this is important. You have to make sure if it's written beside the x, you have to divide that out before you do it. Because that changes what's inside. Where? This one is the reflection over the y, correct. Which you would miss, right, if you didn't factor that out. Let me ask you though, y'all, a reflection over the y for a parabola, does that change anything? Because we have the axis of symmetry, right? So that doesn't change. It's just like the absolute value, right? Remember when we flipped it, it didn't change it? Same thing with the parabola.